This is the Year 7 Particles Reverse the Classroom. So we're going through all the different bits of factual information before you actually do the unit itself to give you an idea about what's going on. Right, this is the route through. Right, we start off particle model, we talk about states of matter, we talk about melting and freezing, we talk about temperature, diffusion, gas pressure, and then what you do is you get testers at the end. Now these three things are practicals that I'm going to kind of talk a little bit about during it. It's perfume, boiling water and potassium permanganate. Now these are practicals that show evidence of particles, right, and it'll become clear as we go through. Particles in a solid, nice rows. Particles in a liquid, kind of jumbled up a little bit with gaps. Particles in a gas, all over the place. Now what this diagram here now does is something that you just got to know. We've got our solid, liquids and gas. We need to talk about the strength of the force of attraction. So the force of attraction between each one, I'll change that from string to strong, right, is very strong, the force of attraction. The force of attraction between liquids is strong, but less, so they're kind of all over the place. Packing, particles in a solid are very closely packed. In a liquid, they are packed together, right, but with gaps, so you can see kind of little gaps in here. And particles in a gas are moving around freely. Motion, particles in a solid vibrating in a fixed position, so they're kind of just in one individual position. Particles in a liquid slide and roll over each other. Particles in a gas are far apart. Now, change of state triangle. So we've got solid, liquid, gas. So firstly, we'll go from solid to liquid. Solid to liquid is melt. Liquid to a solid is solidify, but I much prefer freezing. Liquid to a gas is vaporization or boiling. Gas to a liquid is condensation. Then the weird one then is solid straight to a gas is something called sublimation. Right, an example of that is dry ice, where you've got carbon dioxide as a solid that goes straight to a gas. Gas straight to a solid is something called deposition. Right, and if you think about it, deposit is where a gas gets deposited straight as a solid. Now this is a heating graph and a cooling graph. It's basically the same as the triangle that we had there previously, right, but in a different form. So what we do is you start off with a solid, it warms up, A to B, it turns into a liquid. B to A is where it's freezing, so that's liquid to a solid. Solid to a liquid is melting. B warms up, warms up, warms up, warms up, gets to here, and then what it does, it starts to turn into a gas. When it turns into a gas, vaporization. When it goes then from a gas to a liquid, condensation. Right, and all the way through this, what's happening is the kinetic energy is increasing as you go from a solid to a gas. Diffusion. Diffusion is the movement of particles of any substance in solution or particles of a gas from an area of high concentration to an area of low concentration without the use of energy, which therefore means it's passive. Sometimes you can also get in it down a concentration gradient. Right, two examples here where what I've got here is I've got little purple blobs, right, in a liquid. What happens over time is they move from an area of high concentration, which is here, to an area of low concentration, which is everywhere else in the actual beaker itself. And in a gas, somebody walks in with perfume, spray the perfume, and what happens is you've got a high concentration here, and what the particles do is they spread out by diffusion, going from a high concentration to a low concentration, but it's passive. Now this is then one to do with temperature, right? So what I've got is I've got 10 degrees, 25 degrees and 80 degrees. I put in a piece of potassium, I'll put the second part of it here, permanganate, into a beaker. And what you're going to do then is you're going to time how long it goes from a lump of potassium permanganate entering to where it is spread out completely. And you'll find that the higher the temperature, the faster the rate of diffusion is. Demonstrating gas pressure. Gas pressure is great, it's great to watch. So what you've got here is you've got particles of gas inside the container giving pressure outwards. You've then also got particles giving pressure inwards. And what they do is they're exactly the same. If you take out all the air particles out of the middle, you've then only got pressure from the outside. And if you've only got pressure from the outside, what happens quite dramatically is the can collapses. Now, this is an explanation of how gases can be compressed, and it's all to do with the kinetic theory. Right? If you've got an area, right, which has got gas particles in, what happens is it creates pressure on the outside. So the gas particles are hitting the outside. If you reduce the size of the area the gas particles in, because you've got the same number of gas particles in a smaller area, what happens is there is more hits on the side. And if there's more hits on the side, that means then there's an increase in pressure. Now your questions. What you need to do is you need to write out these questions into your exercise book. All right. Question number 1 is write down a definition of diffusion, a sentence. Number 2, draw and label the change of state diagram, which is your triangle. What theory explains why gases can be compressed? 2 words. What is the motion of solid particles and what is the arrangement of gas particles are then quite short. Now what you've got to do now is you've got to go for your understanding, right? You need to understand exactly what is talked about in this video, right? And if you don't understand something, go back and have another look at it.